Hi everyone, thanks for coming to our talk. Now we're going to talk about new methods for exploiting ORM injections vulnerabilities in Java applications. Let me introduce myself. My name is Mikhail. I'm a security researcher and bug hunter from Russia. Currently I work for Ingram Micro Cloud as application security engineer. My daily duty is to perform penetration testing of software, service automation software we develop at Ingram Micro Cloud.
And my name is Sergey. I work for Kaspersky Lab as head of security operations center. And this research is not connected to my work. This is rather a hobby. Another my hobby is music. I present at Twitter and have personal blog where I discuss my thoughts about information security and even psychology and all that stuff that directly or indirectly connected to IT security. But unfortunately, all this stuff in Russian. But thanks Google, it's not a problem now.
Okay. Here you can see an agenda of our talk. It consists of four main parts. It has an introduction part. We'll shortly talk about what ORM is. The next part is about ORM injection vulnerabilities basics. The majority of slides are devoted to exploitation techniques we uncovered in different ORM libraries. And in the last part of our talk, we will summarize our techniques and present them in the form of tables for your convenience. I want to say that last year on Zero Nights conference in Russia, we already presented some exploitation techniques for Hibernate ORM library. And in this talk, we will present new methods for new techniques for exploiting ORM injections in Hibernate, and also will cover other ORM libraries used in Java. Let's talk about ORM in general. ORM stands for Object Relational Mapping. It's a programming technique for converting data between relational databases and object-oriented programming languages. On this picture, you can see ORM is the question box in the middle between database management system and Java application. ORM communicates with database management system, fetches data from tables, and automatically converts this data into Java objects. Here on the slide you can see some of the advantages for using ORM in your Java application. Of course, you can use plain JDBC and implement everything by yourself on application side. And in some cases it makes sense when you need specific functionality or performance is very critical to your application. But for the majority of cases, using ORM library in your application gives more benefits than implementing everything from scratch via plain JDBC. Okay, what is JPA? JPA stands for Java Persistence API. It's a standardized API which is exposed by ORM library. So Java application communicates with ORM through this API. There are three main versions of JPA, and most ORM libraries support JPA 2.0. There are a lot of ORM libraries in Java. On the slide you can see four libraries that are used mostly in practice. And in brackets you can see G2E application servers that are shipped with a particular ORM library. So in our research we focused on these four libraries, but I'm pretty confident that Based on techniques we have discovered, you can find similar exploitation techniques for other ORM libraries. ORM libraries utilize special query language which is called Java persistence query language. It is used for mapping data between database tables and Java objects. And for historical reasons, Hibernate ORM uses different language, which is called Hibernate query language. And HQL is a superset for JPQL. And since GPA 2.0, there is criteria API. This is a set of interfaces and classes to construct query programmatically. So in your Java application, you can have two alternatives. You can use string JPQL queries, or you can construct queries programmatically via criteria API. And criteria queries are checked at compile time. It is the code becomes more safer because it's harder for the developer to introduce a security bug. I want to explain briefly what ORM injection vulnerability is and what limitations exist for its exploitation. We can also name ORM injections JPQL injections or HQL injections when we talk about Hibernate ORM. And we can say that ORM injections are similar to classic SQL injections in how they looks like in the source code of the application. Here on the slide you can see example of function that is vulnerable to ORM injection. JPQL query is constructed by string concatenation. There is a static part, and it concatenates with name parameter that is controlled from outside of the function. Then this query is used to get data from database and construct a list of Java object of class post. I want to emphasize that SQL injection and JPQL injection are similar in how they are introduced in the source code, but from exploitation perspective they are completely different. Here on the slide you can see SQL injection scenario. Attacker can inject custom SQL statements through injection vulnerability in Java application and obtain data from database. So in this scenario he can communicate with database directly through injection. For ORM injection scenario, there is ORM library in the middle between Java application and database management system. Attacker can inject JPQL or HQL queries and to obtain Java objects from ORM library. In this scenario, he cannot communicate with database management system directly. And ORM is the main obstacle for the attacker he has to bypass. Unequipped attacker will likely feel frustration trying to exploit ORM injection. And there are three main reasons for that. JPQL or HQL have weird and limited syntax. So not all SQL statements will work. For example, JPQL does not support unions. A database, from JPQL query you can't access arbitrary tables. You can access tables in database that are mapped directly to entity classes. If you will try to access tables that is not mapped, you will get exception from ORM. And the third reason is that your favorite tools for SQL injection exploitation will not work with ORM injection. Okay, Java developers might argue that in practice nobody writes GPQL queries by using string concatenation. And vulnerability is more artificial and theoretical than practical. But I want to convince you that it isn't true. So here you can see the short list of vulnerabilities for the last year I'm aware of. First example is HQL injection. I have found by myself internally when I performed security assessment of our products. Next example is HQL injection in Open Brava ERP system. And the third example is HQL injection in novel service desk software. For studying ORM injections, we developed a vulnerable Java application which is available on GitHub. You can download and play with it. Before discussing exploitation techniques, I want to show how, in general, ORM library works. There are three main steps or phases. On the first step, ORM library parses GPQL or HQL query and builds GPQL or HQL abstract syntax tree. Then on the next step, it translates GPQL AST into SQL AST. And finally, it builds SQL query from SQL AST. Now I want to give the turn to my colleague, Sergey, who he will start to talk about exploitation techniques.
Okay, let's start with Eclipse Link ORM. Eclipse Link is a mapping and persistence framework that is under stewardship of Eclipse Foundation. It is designed for use in Java environment, including Java Platform Standard Edition, Java Platform Enterprise Edition. Diving into documentation, we found that this ORM has a magic function, and guess now how it's called? It's called function. This function, it's worth noting that this function exists because of reported bug. Developers complained that they need a functionality to call arbitrary database function, and now this function is present. And the thing is that it works rather silly. It takes first its argument as function name, database function name, and all other arguments put into round brackets to form database function call. On slide you can see how it works, and exploitation is rather silly. This technique works for any database management system, and this is example for PostgreSQL, and green asterisk shows custom injection point. And now let's see small video how exploitation looks like. Okay, we have our vulnerable application, HQL playground. It returns JSON when working correctly. Okay, let's put our magic function into URL and see what will happen. Okay, it's internal server error. Let's see what expression caused this error. You see, it seems to be function call because we have opened and closed round brackets after this expression. Let's add something to URL to form a valid database function call. let it be length, and of course we pass valid argument to length. It's 3a, and the length of 3a is 3. So now it's working well. And you can form true and false expression to exploit blind SQL injection. So okay, that's all. We have to copy this and put into our SQL map. Specify database management system, technique is blind, and B flag means retrieve banner. We need to specify custom injection point. It's the same place where we changed 1 to 2 to form true and false output. So actually that's it. Now we should receive banner. This is not the first time I see this video, so I'm sure banner will come. So SQL map said that it was found asterisk, and parameter is vulnerable, and we can see banner. So what happened? We have vulnerable application and object map to database, but because of vulnerability, we have access to database banner. But banner is not interesting. And let's try to retrieve something more convenient. For example, let's try to enumerate databases and see what will happen. Actually, it works. So it's information schema, PG catalog, public. The most interesting for us is public because all others are default Postgres databases. Let's enumerate tables from database public. Again, the same questions, asterisk, yes. So we have post and users tables. Let's dump users table because it seems to be interesting. Specify capital T flag, users table, and flag dump to dump it. Okay, something happened. Oh, sorry, you will already see this. But believe me, this works. Okay, let's continue. The second, our patient is top link ORM, and it's very similar to Eclipse link, and it has a function with another name, but with the same functionality. And here you can see abstract from documentation that explain why we have SQL function. Actually, documentation for this function is very useful. If you want to figure out how to exploit this very vulnerability, just look into documentation and vulnerable example right in the documentation. So this is example of true. This is example of false. And exploitation is completely the same. This technique works for every database management system, for any database management system, because it's ORM feature. Okay, OpenGPA. OpenGPA is open source implementation of GPA distributed under Apache license. In this ORM we found a number of vulnerabilities with quotes. The first one we called wrong single quotes processing, and we called our method in the same way. The problem here is that this ORM substitutes all sequences of 2 single quotes by 1 single quote. And this strange behavior can allow to hide select statement within string. how exploitation looks like. You can see this line, and we have string with single quotes that correctly escaped. But because of this functionality with wrong single quotes processing, all sequences of 2 single quotes will be substituted by 1 single quote. And the meaning of this expression will be changed completely. On slide you can see how to form true expression and false expression for blind SQL injection. Exploitation looks like this. And this technique works for every database management system. And on slide example is for Postgres. Another interesting feature about Apache OpenGPA is that it has vulnerability that we called quotes indifference. The problem here that it allows to limit strings with different kind of quotes. So for example, you see on slide string that starts with double quotes and ends with single quotes, and this is correct string definition. And of course, this can be exploited, and exploit looks like this. ORM sees in this line string in double quotes with single quotes inside it. But because of this feature of quotes indifference, database management system finally gets comparison A and select statement compared with 8. So the meaning of this expression changed completely. Exploitation looks like this. And again, this technique works for every database management system. And here, example for PostgreSQL, green asterisk is custom injection point for SQL map. Hibernate. Hibernate is the most interesting ORM. That's because we didn't manage to find universal exploitation technique. But we uncovered 5 different techniques for different database management systems.
We named the first technique single quote escaping. The technique works for MySQL database management system only. It works because MySQL and Hibernate process quote escaping differently. So we can see that in MySQL to escape single quote you must use slash symbol before the single quote. But in Hibernate you must double single quote to escape it. We can use slash symbol with 2 subsequent single quotes characters to bypass Hibernate and inject arbitrary SQL query. So you can see that Hibernate will treat slash with 2 single quotes as slash with escape single quote. But MySQL will treat this as escaped quote and single quote that terminate the string. And the part of the string that comes after slash with 2 single quotes is treated as additional condition by MySQL. If we inject following expression into vulnerable parameter, we will get the following HQL query, which is processed by Hibernate. And Hibernate process injected expression as string. But when MySQL gets SQL query via JDBC after HQL query was processed, it will obtain mutated SQL query with additional select subquery. To exploit HQL injection when MySQL database management system is used, you can use the following SQL map command line.
Another interesting technique is, we called it dollar quoted strings method, was presented for us by PostgreSQL and H2. It's worth noting that these two database management systems allows dollar quoted strings, constants. So on slide you can see string dollar dollar AAA quote BBB dollar dollar. It's correct string definition for these very databases. On the other hand, Hibernate ORM allows identifiers starting with dollar, and here you can see a fragment from Hibernate grammar specification. Composing all these facts together, we can make a hack. Suppose this string. HQL understands it as comparison with identifier dollar dollar with string that started with double dollar. But SQL understands the same line differently. It understands string quoted with double dollar signs compared to concat function. And the exploitation of this idea looks like this. Again, this technique works only for PostgreSQL or H2, who allows database which allows double dollar quoted strings. And green asterisk, as usual, our custom injection point.
The third method, we named it magic functions method. And it works against database management systems that have magic functions that we can use in SQL expression. And there are these magic functions evaluates SQL query from string parameter passed to this magic function. And there are magic functions for PostgreSQL and Oracle. And the reason why this technique works is because Hibernate allows to specify arbitrary function names in HQL expressions. PostgreSQL has a nice built-in function query to XML. It evaluates SQL query from string parameter and returns XML object. That XML object represents query execution results. But we cannot use query to XML directly in HQL query. That is why we need to surround it with XPath and array upper function calls additionally. So if we use following expression shown on the bottom of the slide in HQL query, we can info whether SQL query marked yellow returns 0 or more rows. So if we inject into vulnerable parameter following expression, you can see that PostgreSQL will get SQL query with query to XML function call. You can exploit ORM HQL injection when PostgreSQL is used using following SQL map command line. In my YouTube channel, you can find the video about how this exploitation method works. For Oracle, there is getXML magic functions. If you inject following expression into HQL with NVL to char and getXML functions, you can info whether select query that is marked yellow returns 0 or more rows. To exploit HQL injection with Oracle database management system, you can use following command line. The next method has name Unicode. It turns out that some database management systems allows to use Unicode delimiters like this Unicode symbol 00A0 as token delimiters in a SQL query. So we found that Microsoft SQL Server and H2 databases allow Unicode delimiters. So in SQL Server, these two queries works the same. In the first query, you can see that we use Unicode delimiter with code point 00A0. There are many Unicode symbols that works for Microsoft SQL Server as token delimiters, but for exploitation, these two works. These two symbols work. This is a no break space and ideographic space. Let's see why does this method works. On the slide, you can see the snippet from HQL grammar. And the rule that is marked red on the slide tells us that Hibernate allows to use Unicode symbols in identifiers. So if we inject following construction into vulnerable parameter, we will get the following HQL query. And %C2% A0 is URL encoded and UTF-8 encoded no break space Unicode symbol. Here is the part of HQL AST. Here is the HQL AST for the part of HQL query that contains Unicode symbols. This part is marked yellow on the bottom of the slide. We can see in AST not with len function call, then not with nested function call, which has a name that consists of one Unicode symbol with code point 00A0, and this nested function has argument identifier not. In this identifier, we hide SQL query by using Unicode delimiters. That is how we bypass Hibernate with Microsoft SQL Server. Unfortunately, we cannot use SQL map to exploit or HQL injection using this method. So first time we wrote a simple Perl script for exploitation, but it has one drawback. It works against our test application. So if you want to use it, you must tune it. It is available on GitHub, and you can watch the video how it works. But we did not give up and decided to tune a SQL map. We wrote hibernate.py tempo script and modified queries.xml file. You can find these two files on GitHub. To extract something from a database using Unicode method, we use queries that are similar to these queries. So here we extract first 8 rows of column pass W from table users. And these queries have special form because we must convince Hibernate that we are performing a function call. Inside this function call, we perform nested function call with some arguments. That is why we cannot use equal or not equal operators. We use like and not like instead. Let's see how to exploit HQL injection with Unicode method and SQL map. First, you need to copy hibernate.py and queries.xml files and place them into SQL map home directory. Then you need to find injection using the first command line. And finally, you exploit HQL injection using second command line. And let's see the video, how it works.
Okay, as usual, I show a video how exploitation looks like. Can you see something? Okay, this is our vulnerable application. Let's try our long URL with Unicode. And here is a true. Changing where condition we can get false. Okay, that's it. We need to copy this. First of all, we need to copy hibernate.py into tempo folder in SQL map home. Sorry for Russian Windows. We need slightly different queries, so we wrote our queries.xml, and we need to put it into XML folder. But we recommend you to preserve original one. This means copy. So we are prepared now. On first step, let SQL map to find an injection. This is the command. Okay. On the second step, we need to specify our tempo script. You see flag tempo, hibernate, right near this bullet with. And you can see banner, as usual. But banner, as usual, is not interesting. Let's try to enumerate database host name. It's Slava-PC SQL Express. Slava, it's Russian name, by the way. It's my father-in-law computer. Now we already enumerating databases, and it's Masted, MDB, Model, MSDB, HQLI. The most interesting for us is HQLI because all others are default database for SQL Server. Okay, let's enumerate tables from HQLI database. It's post, users. As usual, the most interesting for us is table users. Let's enumerate columns from users table. And users table has username column and password. Unfortunately, our method allows to dump data from table only field by field. But to our mind, this is better than to use custom Perl script because SQL map usage gives us better flexibility. To specify a row num that we want to dump, we need to set environment variable for our tempo script. Set row num to 1. This, and again, we specify table name, column name, database, technique is blind. Oh, where are we? Okay. And okay, username is admin. To get password, you need to set capital C flag to password, and you get something very interesting. Okay, to get another string, to get another row from database, you need to flush session before. So this is the command that flush session. And after that, you need to set environment variable to dump another row. Again, specify username. So gdo and capital C password, dumps password. Okay, and that's it. Actually, we can go to our database management system and find the slout.pc HQLI database that has users table, and it has 2 rows with exactly the same data. Okay.
The last method we want to present is called Java constants method. This method works for the most database management systems except MySQL. But it heavily depends on classes that are on the class path of the application we are attacking. The reason why this method works is because Hibernate resolves fields of public static classes through dot delimited identifier. So we can specify, for example, java.lang.character.size in our HQL query, and Hibernate will replace it to 16. If we are referencing public static fields of type string or char, Hibernate will additionally surround them with 2 single quotes. So java.lang.character.meanValue will be replaced with just 2 single quotes. So to use this method, we need classes on class path that have public static fields of type char or string that have single quote. For example, public static field of type string that contains 1 single quote is suitable. Part of HQL query that ends with single quote is also suitable for exploitation. Or char fields are also suitable. On the slide you can see 5 different representations of single quote for char type. Or you can use interface class with static fields. So public is not mandatory because in interface class all fields by default are public. We search through Java libraries to find suitable fields for exploitation. And we found 2 very popular libraries. They are ICU4J and Logback. These libraries have classes with public static fields that are suitable for exploitation with names single quote and single quote char. And as I said, this is 2 very popular libraries, and it will probably likely that they will encounter in the class path of the application you are taking. Now let's see how this method works in details. So we inject following expression into vulnerable parameter. In this expression, we multiply Java constant c_quote_1 to result of function call with name x, and this function has a string parameter. So on the bottom of the slide, there is a HQL query that is processed by Hibernate. Here you can see HQL AST for the part of HQL query that is marked yellow on the bottom on the slide and contains Java constant. Here we can see Java constant node in the AST marked green, and also we see string node that is marked red. After Hibernate parses HQL query, it builds HQL AST and then translates this AST into SQL AST. Here we can see SQL AST for the HQL query. So we can see that nodes, Java constant node and string node nodes are translated unchanged into SQL AST. And we see that Java constant is not yet resolved. And on the final step, HQL translates SQL AST into SQL query. And on that step, Java constant is replaced with 3 single quotes. And we see that SQL subquery that was concealed inside string parameter of function x is exposed. Just a quick check. When we add where clause, that is always true to the SQL subquery we hide inside a string parameter of function x. Application returns 1 row to us. But when we change this clause to always false, it returns nothing. This means that our technique works. To exploit HQL injection with Java constants method, you can use following SQL map command line. And quick video.
Quick video with Java constants. So please forgive us. I know we all hungry, but just this is with DB2 example. It's a very good database. So again, our application. This is our long URL with Java constant. So again, this is true. Changing, we can get false. Copy it. And there's again true. Copy it in SQL map. Database here is DB2. Technique is blind. And here it is our custom injection point. Actually, that's all. We get Bene. Bene is not interesting. Let's dump databases. It's DB2. It has a lot of databases. Because it's default database installation, a lot of examples and other interesting materials. But the most interesting for us is DB2 inst1. So this is our database. Let's retrieve tables from this database. And as usual, DB2 has a lot of tables. But it's really interesting to see how SQL map works in multi-threaded mode. That's actually, it's rather quick. Can I help somehow? Boom. Oh. Project. A lot of tables. It's DB2 example tables. Post. This is our post that is mapped to our application. And this is users that we're gonna dump in our final command. Okay, T users dump. And everything will be good, I know. Name. It's column name. Password. Admin. 32. It's the length of password. Actually, it's password hash. The second row, VI Lenin. Who doesn't know who is Lenin, just ask me. Okay, actually that's almost it. Just a second. Okay. And some final words from Mikhail.
Yes, and here is the final part of our presentation where we will summarize our techniques for exploitation. When you have found ORM injection, before exploiting it, you would probably want to know what ORM library you are targeting. So you can use the following table. You just paste payloads, different payloads into vulnerable parameter and see what payload returns a valid response from application.
And here, this is actually the final slide because we gathered together all methods we presented in our presentation. And this table shows which method works on each ORM database combination. We hope this table will be useful for you because it contains all words we have just said. And we hope our findings will be useful for your future work. And if you have any questions, we will try to answer. Thank you for coming to our session.
So we have time for 2 questions, and then lunch already started, and then we go to answer. So 2 questions.
So it's interesting how you figure out that you have an ORM injection compared to an SQL injection. How you detect them? Like what was the idea?
The majority of Java applications now use ORM libraries, so it is incorporated into G2E application server. So if you can see that you are facing, for example, JBoss or Whitefly, you know that this application will probably use ORM library.
Yeah, but how you know that you have an ORM injection? Like how you detect it in the beginning?
You detect it as just SQL injection. So our
Just Boolean stuff. You just like
yes, it could be error-based, but it works. Exploitation method works the same, so it will be faster than error-based technique will work faster than blind technique. Or you can use the following table, just paste this, and
To figure out which ORM is used.
yes. And if it is SQL injection, you will always get invalid response from application because
when you like initially find some Boolean stuff, it behaves like an SQL injection. Yeah.
Yes.
One last question from the audience. No? Guys, then I invite you all to attend lunch downstairs. Thank you.
Thank you.